Right, students? So in the last class we discussed about the unit 2 atomic structure, that is what? Orbit and the orbital, correct? So this is unit 2 atomic structure. Okay, so in that we discussed about orbit in the last class. Today we will discuss about orbital. Okay, students. So I'll write from here, that is orbit and orbit. First I will say orbit. Orbit means what? The circular path. The circular path around the nucleus where electrons revolve. It's called as what? Orbit. So this orbit is represented by KLMN, that is denoted by, and the numbering is done by 1, 2, 3, 4. This shows what? Different energy shells. Okay. So another one, students, the maximum number of electrons fill up in particular shell is equal to how much? 2n square. N is what? I write 2n square. N nothing but 1, 2, 3, 4 values. So I said for K shell, n is equal to 1. Therefore, 2 into 1 square, that is 2. So 2 electrons can filling up of 2 electrons takes place from this electron. Okay. Next, K shell over L shell. So for this L shell, n is equal to 2. So therefore, 2 into 2 square, that is 8 electrons for L shell. Next, M shell. M shell, n is equal to 3. So 2 into 3 square, that is 18 electron. Correct? Last, that is N shell. So n is equal to 4, and 2 into 4 square, that is equal to 32 electrons. Okay, students? KLMN shell. So this is the orbit. So in the last class we discussed about this orbit. So today we will discuss about orbital. Orbit is different, orbital is different. So students, what is orbital means? It is the three-dimensional arrangement or a three-dimensional structure where the electron density is maximum. Okay. So orbital means the three-dimensional structure where the electron density is maximum, that is called as orbital. So it is a three-dimensional region. Okay. So, three-dimensional region around the nucleus, where the electron density is more. Where the electron density is more. So students, so in this orbital, 4 different types of orbitals are there. So that is S orbital, P orbital, D orbital and F orbital. SP, like here KL and shell is there. Similarly here SPDF orbitals are there. So here they have the particular shape and particular orbital. So listen, this one is spherical in shape. Okay, so this is like this dumbbell shape, and D means like this double dumbbell shape. Okay, and this one is like this. We cannot determine the shape of the orbital, so this is complex. Okay, students. So, for example, as I told you, you know carbon is there, correct? So, carbon is atom with the atomic number 6, that is 1s2, 2s2, 2p2. Assume, okay? Alright. Instead of carbon, I will take boron with atomic number 5. Atomic number is 5. In this electronic configuration, 1s2, 2s2, 2p1. Okay, students? So this is the nucleus. Proton also 5, neutron also 5. Assume this is 10. Assumption only. Okay. So next, here, one s orbital is there, that is spherical in shape. So, I can write here, this is boron. Okay, s orbital is there, that is spherical in shape. At the same time, p orbital is there, that is dumbbell shape. Understood? It is in this manner. Okay, so this gives what? The shape of the orbitals. Here the electrons present. If one electron is there, either here or here, the one electron present. Understood? So this is the three-dimensional arrangement of a three-dimensional region where the electron density is more. Okay, they form a sigma bond, they form a pi bond. So similarly for carbon you consider, so 2s and 2p orbital you consider, students. This is s orbital, this is p orbital. Okay, 2p2. So it is in this form. Okay, so I write like this. This is s orbital. Okay, if s orbital is there, they are spherical in shape. If p orbitals are there, that is dumbbell in shape. Okay, that is all comes under chemical bonding. So in the next class, next chapter, chemical bonding is there. In that I will explain, student, what are the shape of the molecule, how they overlap, how the sigma bond forms, how the pi bond forms. Okay, so in that I will say overlap of the orbital. Now you just assume the orbital is the three-dimensional region around the nucleus where the electron density is more. Okay, so these are the SPGF. So here, number of electrons to be filled in orbital. Number of electrons to be filled in shell is 2n square. Number of electrons to be filled in orbital, SPGF orbital, is 2l plus 1. 2 into 2l plus 1. 2 into 12 plus 1. So students, for s orbital, L value is 0. For p, L is equal to 1. For d, L is equal to 2. For f, L is equal to 3. These are our quantum numbers. You just remember the values. L is equal to 0, then it is s. L is equal to 1, that is p. L is equal to 2, that is d. L is equal to 3, that is f. Okay. So, the number of electrons to be filled in orbital is 2 into 12 plus 1. So, consider for s, L is equal to 0, correct? 2 into 0 plus 1, that is 2 into 1, 2. In s orbital, maximum electrons filled is only 2. Okay, next, p orbital. So, p orbital, 2 into L value is 1 plus 1, that is 2 into 3, that is 6. Correct? For d orbital, 2 into 2 plus 1, that is 2 into 5, that is equal to 10. And last, F orbital, that is 2 into 3 plus 1, that is 2 into 7, that is 14. So in the S orbital, only 2 electrons can fill, B orbital 6, D orbital 10, F orbital 14. Okay students, so this is the maximum number of electrons to be filled in what? SPTF orbital. So this is 2, 8, 18 and 32, that is shell. What is the difference between shell and orbital? I'll explain now. Okay, I hope you understood. This is orbit, the circular path around the nucleus where the electron revolves. Okay, so orbital means a three-dimensional region where the electron present. Exactly where the electron present is the shell. So S, P, T and F. This is main shell, this is subshell. Okay, so you remember these values. For K shell I wrote 2, L shell I wrote this, M shell I wrote this much, N shell I wrote this much. Okay, so you remember this one 2, 6, 8, 10, 14. Okay, I'll leave that and drop only this much to you people understand. So students, listen here. K shell means that is one S orbital. Okay, L shell means 2s 2p orbital. M shell means 3s 3p 3d orbital. N shell means 4s 4p 4d 4f orbital. Okay, so now S orbital is there. To S orbital, how many electrons can fill? 2 electrons. Correct? For S orbital, again 2. For P orbital, how many? 6. So next, for S orbital 2, P orbital 6, D orbital 10. For this, 2, 6, and 14. Okay, students, these are shells which consist of different number of orbitals. Okay, here only one orbital is there, here two orbitals are there, sp, here three orbital spt, here four orbital sptf. So shell consists of all the types of orbitals based on their energy level. So now you count the number of electrons. Here it is 2, here it is 6 plus 2 8, here it is 6 plus 2 8 plus 10 18. And here it is 6 plus 2 is 10 plus 14, that is 32. What I wrote here, for K shell 2 electron, for L shell 8 electron, for M shell 18 electron, and N shell 32 electrons. Okay, so in the orbital you assume this, the number of electrons filling up are divided according to the orbitals. Okay, so this is the relation between the orbit and the orbital. Okay, students, I hope you understood what is orbit and what is orbital. Next, there are some rules are there to fill up the electronic configuration. You know that some atoms are there, we write it that we divide the number of electrons based on the different energy levels. So before going to that, we have to follow some rules here. First I write the rules, after that I will explain the energy level diagram and why it is like so. Okay. Four rules are there in which the way the filling up of electron can take place in a proper way, students. So in that, first one is, okay, so in that first one is rules. Okay, first one rule is of work principle. Of work principle. What it says of a principle? So the electrons are filled. Electrons are filled in orbital in the increasing order of their energy. This is the first one. Of principle means electrons are filled in orbital in the increasing order of their energy. First principle, of principle. Second one is that is Paul's exclusion principle. Paul's exclusion principle. What is this Paul's exclusion principle says? So student, no two electrons in an atom can have same set of quantum numbers. Okay, no two electrons in an atom can have same set of quantum numbers. So third one is Ohm's rule. Okay, so what is that Ohm's rule? Electron pairing takes place. Electron pairing will take place only after all the orbitals are singly filled. Okay, so the last one is N plus L rule. Last one is N plus L rule. So in this N plus L rule, the minimum value of N plus L will come first. So, okay, these are the four rules which define how the electrons filling up takes place in the different orbitals and the different shells. Students. So first one, electrons are filled in the orbital in the increasing order of their energy level. First lower energy level fill up takes place, next higher energy. Okay. Similarly, next one is Paul's exclusion principle. No two electron in an atom can have same set of quantum numbers. So quantum number is a type of or it is one of the atomic model and nowadays we are using. As I told you, the atomic models are explained by so many scientists discovered the different atomic models, but in nowadays we are using the quantum atomic model as the basic model. Okay, so what is this quantum atomic model? It clearly explains the different energy cells, where the electron present, where the proton, neutrons are present. Everything is explained by the quantum atomic model. Okay, so Ohm's rule means electron pairing will take place only after all the orbitals are singly filled. So n plus 1 rule means the minimum value of n plus 1 value fill up takes place. Okay, fill up first. Okay, remember this thing. I'll explain first quantum numbers. Okay, students, I'll take example carbon. Its atomic number is 6, configuration is 1s2, 2s2, 2p2. Okay, so first one, there are four types of quantum numbers are there. One is principal quantum number. Okay, azimuthal quantum number, magnetic quantum number, and spin quantum number. Okay, so four types of quantum numbers are there. So this is the configuration. I'll compare these quantum numbers with this. Okay, students. So here the principal quantum number means which shows main shell. So represented by M, which shows main shell represented by M. Here 1, 2, 3. That is K and L shell, you know. K, L, M, N shell, main shell is what? This principal quantum number. That is n is equal to 1, n is equal to 2, 3, 4, etc. Okay, students. So azimuthal quantum number means itself tells about subshell represented by L. Azimuthal quantum number represents subshell. This is main shell KLMN. This is subshell. Okay. So here that is N. Its value is, so N is equal to what? N minus 1. The formula L is equal to N minus 1. So listen. For S orbital, N is equal to 0. For P orbital, N is equal to 1. For D orbital, N is equal to 2. For F orbital, N is equal to 3. These are fixed, students. For S orbital, N is 0. P orbital 1, D orbital 2, F orbital 3. Okay. So then this is magnetic quantum number. What is this magnetic quantum number? It shows orientation to the electron. So its formula is M is equal to 2L plus 1. M is equal to 2L plus 1. So I will consider S is equal to, for S, M value what? For S orbital, L value is 0. 2L plus 1 means 2 into 0 plus 1, that is 1. Okay. So P orbital, M is equal to 2 into 1 plus 1, that is 2 into 3. That is 2 plus 1, that is 3. Yeah. For D orbital, M is equal to 2 into 2 plus 1, that is 4 plus 1, that is 5. Okay. So for F orbital, M is equal to 2 into 3 plus 1, that is 6 plus 1, that is 7. So this one shows what, student? Orientation of the atom. Electrons to which atom it will go. So this is, if we want to write the S orbital, we will write like this. For P orbital, like this. For D orbital, 5. For F orbital, 1, 2, 3, 4, 5, 6, 7. Okay, so this will give the magnetic quantum number. So last one is, students, that is spin quantum number. Spin quantum nothing but, you know, electrons are the spin. If they are arranged in a, last one is spin quantum number. That is, they have plus or minus of spin. Okay, so plus or minus of, you may say plus or minus of. If they are in parallel direction, that is plus or. If they are in parallel, then this is 0, because this is plus or, this is minus or, gets cancelled, and this is 0. Okay, students. So the spin quantum number shows the electron direction. Okay, the spin of the electron and the direction of the electron in which it is moving. Okay. So I'll explain now. So listen, alpha principle means electrons filled in the orbital in the increasing order of their energy. Listen, first 1s orbital fill-up takes place, after that 2s, after 2s 2p, next 3s will be like that. So here the electron fill-up takes place what? Based on their increasing order of their energy level. Okay, if you want to write a box diagram for this is S orbital, this is P orbital, S orbital, this is P orbital. Okay, next, Pauli exclusion principle. No two electrons in an atom can have same set of 4 quantum numbers. For example, here N value is 1, L value is 0. Here N value is 1, sorry, N value is 2, L value is 0. Here L value is 2, L value is 1. Okay, so here only the principal quantum number and the azimuthal quantum number varies. They have the different quantum numbers are there. So no one here, no two electrons in an atom, single atom. So in no two electrons, at least a pair of electrons like this, they don't have the same quantum number. Understood? So no one electron in an atom can have the same set of quantum number. Of course, students, if they have n value same, L value same, m value same, then also the spin of two electron, one is plus of, another one is minus of. At least spin quantum number differs. At least spin quantum number differs. Okay. So next one is electron pairing will takes place only after all the orbitals are singly filled. So for example, students, if I instead of carbon, if I take neon, atomic number 10, this is 2p6. Okay, so first what happens, students? They said electron pair will take place only after all the atomic orbitals are singly filled. For example, listen, this is the orbital. First one electron fill up takes place, next pairing up. Here also one electron, next pairing up. Okay, so here first one electron, two electron, three electron. First singly filled, that is the electron pairing takes place only after all the orbitals are singly filled. So all the orbitals are singly filled. Here 6 electrons are there, here 3 electrons are singly filled. Next pair up takes place. This shows Ohm's rule. Okay, this shows Ohm's rule of maximum multiplicity. Okay, students, and the last one is the n plus L rule. The minimum value of n plus L rule fill up takes place first. For example, n value is this 1, 2, 3, 4. L value is 0, 1, 2, 3. Okay, if n plus L value is more, then that filling up takes place first. Okay, about this n plus L rule, I'll explain to students how we understood the quantum number. Okay, this one is necessary. That is not that much necessary. I told you because I wrote here quantum numbers. I create a concept on your mind, so I explained the quantum numbers. Okay, 4 types of quantum numbers are there: principal, azimuthal, magnetic, and spin. Principal quantum number shows main shell, that is KLLM. Azimuthal shows subshell, that is SPDF. This shows magnetic orientation where the electrons present. And spin quantum number shows spin of the electron. Okay, so as I told you, What is this n plus L rule means? And right here, if n is equal to 1, then L is equal to n minus 1. That is 1 minus 1, 0 means S orbital. Okay? If n is equal to 2, n will represent like this. Then L is equal to 2 minus 1. Then L is equal to 1. That is p orbital. Okay? N is equal to 3. L is equal to 3 minus 1. So L is equal to 2. That is d orbital. Next. N is equal to 4. L is equal to 4 minus 1. L is equal to 3. That is F orbital. So students, so this L have value 0, 1, 2, 3, 4 only. But this N may vary. N is equal to 5, N is equal to 6, N is equal to 7. But then you can't do N is equal to 5 minus 1, that is 4 like that, because it ends at F orbital. Because L tells about only one subshell. Okay students, this is N plus L. Remember, you assume 3s orbital, 3d orbital, 4s orbital and 4p orbital. So n value for this 3d is, n value is 3, for d orbital n value is 2. Okay, next, here this is 4 and s value is 0, that is for 4 this is 1. So this is also 5, this is 4, this is 5 students. So in the electronic configuration, which one is the n plus L value? So if you want to write the configuration students, it must be 1s, 2s, 2p, 3s, 3p, 3d, 4s, right? But instead of this, here 4s fill up 3d, 4s. But actual configuration is 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. This is the correct configuration. Why? So listen, 3d, the n plus n value is 5. For 4s, n plus l value is 4. Okay? So if the n plus l value is reached, so listen, I wrote the minimum value of n plus l fill up first. So here, even though it is 4s orbital, this n plus l value is 4. So that's why this 4s orbital fill up takes place first, followed by 3d and 4p. So here 3d also have 5 and 4d also have 5. So if same n plus l value is there students, then if n value is minimum for which orbital, that is very lower energy. So here 3d also having n plus l value 5, 4p also have n plus l value 5. Okay. So in these two cases, n value 3 is less compared to 4. So that means which one has the least n value, that is least in energy. Okay, this is the order of the configuration. Okay, so these all rules tells us how the electronic configuration fill up takes place and what is the rules. Everything is studied in these students. Okay, and as I wrote you the magnetic quantum numbers like spin, right? Okay, so I write all the quantum numbers, then you will come to know. I hope you understood the rules of filling up of the electrons. Then now I will write all the quantum numbers. Then you will easily understand. So, quantum numbers. principle, azimuthal, magnetic spin. Okay, so principal quantum number, if n is equal to 1, L is equal to n minus 1, that is what? Yes, n minus 1 means 1 minus 1, that is 0, means what? R. I'll write here, this is n, this is L that is n minus 1, here m that is 2l plus 1, this is spin, ms, spin quantum, this much enough. So if n is equal to 1, L is equal to 0, which orbital? S orbital. Then m is equal to 2l plus 1 means 0, that is 1 orbit. And here plus or minus half. Next, if n is equal to 2, L is equal to 1, that is p orbital. If L is equal to 1, m is equal to 2 ones are 2 plus 1, that is 3. Which are those 3? So listen students, n is equal to 1 means that is minus 1, 0 plus 1. That means 1, 2, 3, minus 1, 0 plus 1. Here also spin plus or minus half. Next, n is equal to 3, when n is equal to 2, that is d orbital, then m is equal to what? 5. Here L is equal to 2 means the values minus 2, minus 1, 0, plus 1, plus 2. That means 5 orbitals. Here also spin plus or minus half. Okay, next. If n is equal to 4, L is equal to 3, that is F orbital. So n is equal to 7. What are the 7? Minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. This is also plus or minus half. Here 7 orbitals are there. 1, 2, 3, 4, 5, 6, 7. So this is all about the quantum number, students. You have to remember this. Once you remember these quantum numbers, this table is easy, I think so. So they directly ask which type of quantum numbers is there, like that, what is the way of filling up of electron takes place. So what are the rules? This is quantum numbers, principle, n, 1, n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, assuming the and this one. Okay, so this is all about the quantum number, students. In the next class, I will say the different energy levels and what are the rules to write the electronic configuration to follow up to 7p orbitals, and how the and I write the electronic configuration up to the elements with atomic number 30. Okay, in the tomorrow's class we will discuss about the today electronics. Okay, so this why, because this is quantum numbers, this is very important, students. So in the QC examination, it carries 4 marks about the principal quantum number. What are the significance of the principal quantum number? The ask the question carries 4 marks, so that's why I am explaining this. Okay, this is highly important. This is the quantum numbers represented by this 1, 2, 3, 4, and this NA continues, but L ends here, M ends there, and this one also ends here. Okay, you write down this chart and you practice. I hope you understood the quantum numbers. In the tomorrow's class, I will explain the same thing with the electronic configuration, then you will easily understood the quantum numbers. Thank you.